Hello everyone. In this question, it is given that let limit of the summation as k goes from 1 to n of the fraction k cube plus 6k square plus 11k plus 5 upon k plus 3 whole factorial as the limit n goes to infinity is the fraction p upon q, where pq are co-prime natural numbers. Then we have to find the sum p plus q. Okay, so first of all, I'm going to use a formula of factorization. Okay, if you know this, you can apply it directly. But this is the formula that is going to be used here. Formula is, if we are given the product x plus a times x plus b plus times x plus c, this is given as x cube plus a plus b plus c x square plus ab plus bc plus ca times x plus the constant term abc. Okay, so we are given that the limit as n goes to infinity, the sum of k goes from 1 to n, k cube plus 6k square plus 11k plus 5 whole thing upon k plus 3 factorial is equal to p upon q, right? So this numerator, I can write this 6 as 1 plus 2 plus 3, right? 1 plus 2 plus 3 is 6, because if I take 1 plus 2 plus 3, then this is also satisfied. 1 times 2 plus 2 times 3 is 6, right? So 2 plus 6 is 8. Then 3 times 1. So this is also satisfied, and ABC becomes 1 times 2 times 3 is 6. So this becomes k plus 1 times k plus 2 times k plus 3, right? So ABC becomes 1 times 2 times 3 is 6, but there is 5 in the numerator. So I will subtract 1 here upon k plus 3 factorial, and this is n tends to infinity, and k goes from 1 to n, p upon q. Okay, so now if I try to separate these fractions, okay, I can write this k plus 3 as k plus 3 times k plus 2 times k plus 1 times k factorial, and the numerator is k plus 3 times k plus 2 times k plus 1 minus 1 is equal to p upon q. Okay, so if I separate them, this becomes k goes from 1 to n. On separating, this becomes 1 upon k factorial minus 1 upon k plus 3 factorial, right? So if I now start putting the values of k in this expression, this becomes limit n tends to infinity 1 upon 1 factorial minus 1 upon 1 plus 3 will be 4 factorial, right? So this is the first term. Similarly, for k equal to 2, this will become 1 upon 2 factorial minus 1 upon 5 factorial. For k equal to 3, this will become 1 upon 3 factorial minus 1 upon 6 factorial. And then for k equal to 4, this will become 1 upon 4 factorial minus 1 upon 7 factorial. Okay. Now I expanded up to the fourth term because you see this 1 upon 4 factorial and this 1 upon 4 factorial, they cancel each other. Similarly, in the next term, this 1 upon 5 factorial will get cancelled here somewhere, right? And this 1 upon 6 factorial also will get cancelled here. Okay, so this continues up to k is up to n, right? So if k the last term will be 1 upon n factorial minus 1 upon n plus 3 factorial, right? So this term won't get cancelled, like this first term here, second term here, and third term here, these are not getting cancelled, right? Similarly, the last three terms also won't get cancelled, but the terms prior to the last three terms, they will get cancelled. So let me show you the terms that are getting cancelled. Okay, so this term will be there, minus, this is for n k equal to n minus 3. Okay, for k equal to n minus 3, this k factorial is n minus 3, and this n minus 3 plus 3 will become n factorial. Similarly, the term after that will become n minus 2 factorial minus 1 upon n plus 1 factorial, right? And the term after that will be 1 upon n minus 1 factorial minus 1 upon n plus 2 factorial. And then the last term will be for k equal to n. So the very last term will be 1 upon n factorial minus 1 upon n plus 3 factorial. So this is the complete sum. Okay, and this is equal to p by q. So on careful observation, this n factorial will get cancelled somewhere here. This n minus 3 factorial also will get cancelled. This n minus 1 factorial will get cancelled. This n minus 2 factorial will get cancelled. See, this 1 upon n factorial, these are getting cancelled here, right? So the first three terms and the last three terms, 1 upon n plus 1 factorial, 1 upon n plus 2 factorial, and 1 upon n plus 3 factorial, these six terms will be left out. Okay, so this is the limit, right? So we are left with 1 upon 1 factorial plus 1 upon 2 factorial plus 1 upon 3 factorial minus 1 upon n plus 1 factorial minus 1 upon n plus 2 factorial minus 1 upon n plus 3 factorial, and this is equal to p upon q. So if I take the limiting value as n tends to infinity, this will become 0, this will become 0, and this will become 0, right? Since it is in the denominator, and if denominator goes to infinity, the fraction goes to 0. So the three terms will be left out at the first three constant terms. Okay, so this becomes 1, this becomes half, and this becomes 1 upon 6. So this is p upon q, right? So p upon q, if I take the LCM, this becomes 6. So it's 6 plus 3 plus 1. So this is 10 upon 6. So 10 upon 6 is 5 upon 3. Okay, so this is the required fraction. So we were required to find the value of p plus q. So p plus q will be 5 plus 3. This is 8. Okay, so this is the final required answer. Okay, so I just tried to show this whole expansion. Okay, this cancellation of terms. So I expanded it. You can do it directly also. If you know this formula, you can do it in fewer steps. Okay, I just wanted to show this expansion and this cancellation of terms. Okay, so this is the required final answer. Thank you.